Hello everyone, I'm Sudha Salam from Molecular Biology and Genetics Department of Bilkent University, and this video will explain my Physics 101 laboratory final experiment. This experiment was performed in order to observe the theoretical and experimental values of spring constants of serially and parallelly combined springs. The experiment is divided into two parts, the first of them being the part where the spring constant is calculated using elongation, mass, and gravitational acceleration, or simply Hooke's law. In this step, two springs were used. The masses were 100, 150, 200, 250, and 300 grams. These masses were hung to the springs to calculate elongation. In the second part of the experiment, we will be using harmonic motion. The springs were combined serially first. The masses were used again 100, 150, 200, 250, and 300 grams. The time for 10 oscillations was observed, then the time for 1 was calculated. The springs were then parallelly combined, and since their lengths were different, a rope was used to hang the objects. The masses used this time were 200, 250, 300, 350, and 400 grams because I realized that the previous masses were not heavy enough to cause an elongation when the springs were parallelly combined. Each measurement was done 5 times and the average of them was used in the following calculations. After obtaining the results, I did the necessary calculations to obtain graphs for both springs' individual constant. If you redesign Hooke's law, it is clear that the slope of the graph equals the spring constant. Using these spring constants, the theoretical value of the parallel and serially combined springs were calculated. The practical values and the theoretical values are compared, then the error rate is calculated. You observe nearly 16% error in serially combined springs and 50% error in parallelly combined springs. The reason why parallel springs have more error percentage than the serial springs could be the fact that the springs did not have the same length, so while combining the springs parallelly, a rope was used. The mass of the rope was not included in the calculations. Even though it is very light and would not cause a 50% error, it may have had an effect on it. Also, the fact that the length of the springs was not equal prevented me from observing the number of oscillations properly, which I believe is the biggest reason for the error in parallel springs. The common reasons for both errors could be while measuring the time, even though the area of the masses was quite small, air friction could have slowed the spring and affected the mass. Additionally, in both calculations, a piece to hang the objects to the spring was used. This object was about 5 grams and it was not included in any of the calculations, which is why it affected both of the errors. Another factor that affected all the parts of the experiment is, of course, human error. While measuring the elongation, keeping the time for oscillations, even when making the metal discs or making the scale, there's always a human factor that causes mistakes. Thank you for watching.